So we discuss about the periosteal vessels. Now we'll discuss about the periosteal nerves. Look, this is the green indicator is the fibrous layer of the periosteum, and if we remove and here is looking some vessels. What are these vessels? These are the periosteal vein and the periosteal artery, which pierces the fibrous layer of the periosteum and intervenes between the fibrous and osteogenic layer of the periosteum. So now we will remove the fibrous layer of the periosteum. So what can we see? We see the osteogenic layer of the periosteum, and overlying the osteogenic layer of the periosteum there are periosteal vessels, that is arteries and veins, and there are periosteal nerve. The periosteal nerves are nociceptive and transmit pain signals to the central nervous system. The periosteal nerves are a network of nerves located between the two layers of the periosteum, the fibrous layer and the osteogenic layer. Anatomical relations: in cortical bone, the periosteal nerves follow a similar path to the periosteal blood vessels. They form a plexus between the layers of the periosteum before branching into the underlying compact bone below perforating canals. Function: periosteal nerves are mainly sensory nerves that transmit pain signals. Due to the presence of sensory receptors, the fibrous layer of periosteum is the most pain-sensitive area of bone, which can be caused by a number of factors including trauma and osteoarthritis. Here we see another structure, that is the periosteal lymph vessels. The periosteal lymphatic vessels contain lymph from the outer cortex layer and form a network of vessels within the periosteum. Anatomical relations: the network of periosteal lymph vessels is accompanied by the intrinsic periosteal vasculature and sits in between the fibrous and cellular layers of the periosteum. Function: the periosteal lymph vessels provide lymphatic drainage of the outer cortex and periosteum. Now, one by one, we'll remove them. We'll remove the osteogenic layer of periosteum. Now we see the osteogenic layer of periosteum. So the osteogenic layer of the periosteum, the inner osteogenic layer of the periosteum is populated with mesenchymal progenitor cells, which can differentiate into osteoprogenitor cells. The osteoprogenitor cells under the appropriate stimuli may become osteoblasts. When there is no active bone formation, osteoblast cells are flat and have spindle-like nuclei, but upon activation they appear cuboidal. All cells of the osteogenic layer sit in a loose connective tissue layer containing many fibroblasts. The osteogenic layer is well vascularized and has abundant innervation. Anatomical relation: the osteogenic layer is in direct communication with the cortical bone, whereby it provides osteoblasts for new bone formation. The osteoblasts form a layer adjacent to the cortical bone surface. Function: the osteogenic periosteal layer provides the necessary cells for bone growth, modeling, and remodeling. The periosteum works with its osteogenic counterpart, the endosteum, to define and maintain cortical thickness. Now we will remove the osteogenic layer of the periosteum. Now we see the compact bone. Compact bone is bone substance that is dense and hard. The compact bone forms the outer dense covering of bone tissue. Approximately 80% of bone in adult human skeleton is composed of compact bone. Compact bone is comprised of functional units called osteons. Here we see the osteons. These are the osteons. These are the functional units of the bone. In dense compact regions of long bones, osteons lie parallel to each other and are oriented with the long axis of the bone itself and appear round in cross section. Here we see in cross section the osteons are appearing round. In compact bone, osteons are identified by their central nutrient canal surrounded by 5 to 20 concentric rings of lamellar bone. Here we can see the osteons, and we can also see the canals, the central canals or central nutrient canal surrounded by 5 to 20 concentric rings of lamellar bones. The bony matrix of the lamellar compact bone is dense, and only small spaces called lacunae are found interspaced between the osteons of compact bone are non-uniform spaces comprised of interstitial lamellae. The interstitial lamellae have a haphazard orientation, which is in contrast to the circumferential lamellae seen surrounding the nutrient canals within the osteons. Inner and outer circumferential lamellar layers are found lining the internal and external surfaces of compact bone. Anatomical relations. The outer circumferential layer of cortical bone is surrounded by the osteogenic periosteal layer of the periosteum. The innermost portion of the cortical bone is made up of the inner circumferential lamellae. This portion of the inner cortical surfaces is adjacent to the spongy bone. The spongy bone with its irregular trabeculae does not completely cover the internal surface of the cortical bone and is lined by an endosteum. Function of compact bone. The arrangement of compact lamellar bone confers the strength required for structural support to the body. It assists in movement by giving leverage to muscles and by acting as a rigid support for muscle contraction. Compact bone provides structural support for the body and protects internal structures, the heart and the spinal cord. It also acts as a reservoir for important ions such as calcium and phosphate. The release of these ions is very tightly balanced to preserve mineral homeostasis. Now we will here, and you may misinterpret that this this is these vessels lying over the compact bone, but they are actually not lying over the compact bone. They lies in between the fibrous and osteogenic layer of compact bone of periosteum, fibrous and osteogenic layer of periosteum, and the osteogenic layer of periosteum covering the compact bone. We removed the osteogenic layer of compact bone, so they appear as the blood vessels lying over the compact bone, but actually they lie over the osteogenic layer of the periosteum. Here we have read that the compact bone is surrounded the spongy bone. So if we remove the compact bone, then we can see the spongy bone. Here we see the spongy bone. So the spongy bone is bone substance made up of thin intersecting lamellae, usually found internal to compact bone. Structure or morphology. Spongy bone is arranged into trabeculae. These trabeculae form a mesh network of bony spicules of various sizes that are aligned along regions of biomechanical stress. The trabeculae are small semilunar plates of bone of varied dimensions, 50 to 400 micrometer. Trabeculae project into the medullary cavity from the internal circumferential lamellae of the cortical bone. The trabecular bone is a laminated bone with occasional osteons present. Osteons are seen in thick portions of trabeculae, primarily in parts closest to the cortical bone. Spongy bone is similar to cortical bone in the fact that it is laminated, but osteons are most likely to be present only near cortical bone or in the thicker trabeculae. As it is often devoid of osteons, it relies on diffusion of nutrients through the extracellular fluid within the canalicular system. Anatomical relations: spongy bone sits inside the internal circumferential lamellae of the cortical bone. It is lined with endosteum, which separates it from the marrow cavity internally. The endosteal layer is irregular in appearance as it tightly adheres to the irregular surface of the trabeculae. Function: the large surface area of spongy bone facilitates metabolic activities. Due to its trabecular arrangement, it is lighter than cortical bone and helps reduce the overall weight of the bone. So, if we remove the spongy bone, we see this is the spongy bone and this is the concentric lamellae, and this is the trabeculae, and they lie within the spongy bone, and there are numerous blood vessels which arising from the periosteal vessels and subnutrient arteries. Now, if we remove the spongy bone, we can see this is what structure? This is the endosteum. This is the endosteum lines the inner surface of the bone of the cortical bone and surrounding the bone marrow. The endosteum is the tissue lining all inner aspects of the bones, including the medullary cavity. The endosteum is a thin osteogenic layer that is lined with osteoblasts and precursors to osteoblasts. In times of inactivity, these cells are flat and not easy to distinguish from each other. Upon activation, osteoblasts become cuboidal and are capable of producing osteoid, which forms new lamellar bone. Anatomical relations: the endosteal layer is a thin but expansive layer. It covers all the trabeculae of the spongy bone along with the inner cortical surface from which the trabeculae are attached to. It also evaginates the perforations that allow the passage of blood vessels and continues into the cortical bone where it lines the perforating canals, Haversian and Bachmann's canals. Function: the two osteogenic layers, the endosteum and periosteum, are responsible for the balance of bone deposition and resorption. Bone resorption is often greater than bone deposition, and thus the marrow cavity expands as we age. Now we remove the endosteum, and now the structure we seen is the yellow bone marrow. Yellow bone marrow is ordinary bone marrow of the kind in which the fat cells predominate. Yellow bone marrow is formed in the medullary cavity of mature bones. As the required rate of blood formation decreases, so too does the red hemopoietic tissue. The red marrow is infiltrated with adipocytes. The adipocytes are responsible for its yellow appearances. In long bones, the majority of marrow tissue is yellow by early adulthood. Anatomical relations: bone marrow sits in the central medullary cavity of bones and sits alongside the medullary vessels which provide vascular supply to the bone. Function: yellow bone marrow is indicative of a reduced capacity of blood formation. However, in cases of trauma and severe blood loss, it is capable of reverting back to red marrow. So this is the yellow marrow. So this is the yellow marrow or yellow bone marrow, and this is the medullary vessels, and this is the veins of the medullary cavity, and this is the arteries of the medullary cavity. The nutrient artery supplies the medullary cavity. Structure and morphology. The medullary arteries are divided. The medullary arteries are derived from several external vessels. The epiphysis, metaphysis, and diaphysis contain several openings in the bone to permit the passage of blood vessels into the medullary cavity. Within the cavity, these vessels branch and anastomose to provide a continuous vascular supply to the entire bone. In the diaphysis, the long bones, the shaft is supplied by the nutrient artery. If you examine the outer cortical surface of long bones, there is normally a singular nutrient foramen in its diaphysis. This marks the entry point of the nutrient artery as it courses towards the medullary cavity. In a passageway called the nutrient canal, the nutrient artery does not branch within the nutrient canal, but upon entry to the medullary cavity, it bifurcates into ascending and descending branches. The branches travel to the outer limits of the shaft and anastomose with the epiphyseal and metaphyseal vascular supply. Anatomical relations. The medullary arteries within the shaft form a rich vascular network that forms the medullary sinusoids associated that drain into a central venous sinus. Outer branches of the medullary arteries travel towards the cortex as the blood flow is traveling from the innermost cavity outward. It is called centrifugal blood flow. In the cortex, it causes through the perforating canals to supply the nutrient canals of the osteon. Function. The medullary arteries form a rich vascular supply for the inner medullary cavity, the spongy bone, and also the inner two-thirds of the cortical bone. So, the medullary arteries form a rich vascular supply for the inner medullary cavity, the spongy bone, and also the inner two-thirds of the cortical bone. Now, there is another structure which is the veins of the medullary cavity. The central sinus within the medullary cavity drains into veins that eventually pierce the endosteal layer and travel within the nutrient canal to exit the bone through the nutrient foramen as the nutrient vein. Anatomical relations. The veins that drain the medullary cavity follow the same course as the nutrient artery and travel within the nutrient canal to exit the bone through the nutrient foramen. However, occasionally they travel separately and exit as an emissary vein. Here we see some another structure. These are the lymph vessels of medullary cavity. The lymph vessels enter the medullary cavity accompanying the nutrient vessels of the marrow. Their distribution in the marrow follows the course of the vessels towards the epiphysis, where they branch off into smaller lymph vessels. Anatomical relations. The lymph vessels of the medullary cavity follow the same course as the nutrient vessels and travels towards the epiphysis. Now we see some structures, and these are the most important because they are the functional unit of the bone. These are the osteon. Here these are the osteon, and the blood vessels are missing here, and there's arteries, veins, and nerves which are missing here. The osteon is the basic unit of structure of compact bone comprising a central Haversian canal and its concentrically arranged lamellae. Of which there may be 4 to 20, each 3 to 7 micrometer. thick in a single Haversian system. Such units are directed mainly in the long axis of the bone. Structure and morphology. Osteons are the cylindrical functional units of bone. In adults, osteons mainly form in existing compact bone through the continuous process of bone remodeling. In long bones, osteons form a parallel to each other and parallel to the long axis of the bone and thus appear around in cross-sectional anatomy. Osteons can be identified by their central nutrient or Haversian canal, which provides a channel for vasculature, nerves, and lymphatics to travel. But here we uh, can see them because they are missing here as we uh, remove them. A population of cells, the osteoblasts produce 5 to 20 rings of lamellar bone. These we can see the 5 to 20 layers of the lamellar bone uh, that radiate outwards from nutrient canal. Haversian canal can communicate with each other by via Volkmann's canal. Haversian canals can communicate with each other via Volkmann's canals, which run obliquely to the axis of the osteons. Osteocytes are formed when actively secreting osteoblasts become surrounded by osteoid and become trapped in a species called lacunae. The osteocytes in their lacunae are parallel to the lamellar rings. These are the osteocytes. We see these are the osteocytes. Are parallel to the osteocytes in their lacunae are parallel to the lamellar rings. These lacunae are connected by small channels called canaliculi. These are the canaliculi. The canaliculi radiate from lacunae in a perpendicular orientation. Osteocytes extend their slender cellular process through these spaces to communicate with each other. These facilitates cell-cell communication via gap junctions. Anatomical relations. In cortical bone, interstitial lamellae are found in irregular orientations between osteons. They are separated from osteons by a thin layer called the cement line. The internal and external circumferential lamellae are the inner and external limits of osteons in cortical bone. Function. Osteons serve as the functional unit of bone. Their thick lamellar rings provide mechanical support and strength to bone. They protect the vascular supply via the nutrient canal. Osteons are constantly remodeling and respond to the biomechanical stresses that they undergo. So these are the osteons. Here we see the clear picture of the osteons. These are the osteons, which is the basic unit of the structure of compact bone, comprising of a central Haversian canal and its concentrically arranged lamellae, of which there may be 40 to 20, each 3 to 4 micrometer thick in a single Haversian system. In a single Haversian system, such units are directed mainly in the long axis of the bone. Osteons are the cylindrical functional units of bone in adults. Osteons mainly form in existing compact bone through the continuous process of bone remodeling. In long bones, osteons form a parallel to each other and parallel to the long axis of the bone and thus appear round in cross-sectional anatomy. Osteons can be identified by their central nutrient or Haversian canal, which provides a channel for vasculature, nerves, and lymphatics. Here we see the nerves, vasculature, nerves, and lymphatics in the osteons. A population of cells, the osteoblasts produce 5 to 20 rings of lamellar bone. Here we see the lamellar bone that radiate outwards from nutrient canal. Haversian canals can communicate with each other via Volkmann's canals, which run obliquely to the axis of the osteons. One osteons to another osteons, or Haversian canals can communicate with each other. This is the Haversian canal, and each communicates with each other through the Volkmann's canals, which run obliquely to the axis of the long bone, axis of the osteons. Osteocytes are formed when actively secreting osteoblasts become surrounded by osteoid and become trapped in a species called lacunae. The osteocytes in their lacunae are parallel to the lamellar rings. These lacunae are connected by small channels called canaliculi. The canaliculi radiate from lacunae in a perpendicular orientation. Osteocytes extend their slender cellular process through these spaces to communicate with each other. These facilitates cell-cell communication by gap junctions. Anatomical relations of the osteons in cortical bone. Interstitial lamellae are found in irregular orientations between osteons. They are separated from osteons by a thin layer called the cement line. The internal and external circumferential lamellae are the inner and external limits for osteons in cortical bone. Function: osteons serve as the functional unit of bone. Their thick lamellar rings provide mechanical support and strength to bone. They protect the vascular supply via the nutrient canal. Osteons are constantly remodeling and respond to the biomechanical stresses. So these are the basic concepts of osteology we should know. So we will discuss its another section of anatomy. Until then, please stay with me and subscribe my channel. Thank you very much.